Okay, welcome back to 5.2. We are looking at exponential functions and their graphs, and this is part 2. All right, we're looking at our next example. We're asked to graph the exponential function of f of x, where that is 1/2 raised to the x, and one thing that they want us to recognize is that these two are inverses of one another. Right, so if we have a 2 to the 1, or 2 over 1, that's the same as a 1 over 2, but we're going to use a negative exponent rather than a positive exponent. So here we have the 0 and 1, both cases. Here I have a 1 and a 2. Here I have a negative 1 and a 2. All right, so in this case it's going, we're taking a look at what's happening, and each of these gives us kind of the same absolute value, but one is positive and one is negative, meaning one is a fraction, or you have a 1/2, and the other is what we would think of as a normal number, or a non-fractional piece where it's a 2 over 1. All right. So I've pointed this out before. I want to make sure that everyone's really clear on this, that 1/2 is the same as 2 to the negative 1 raised to the x, which is the same as 2 to the negative x power. All right, so the two of them are going to be reciprocals of one another. All right, so here we have a decay exponential function, and this is a case where as the x value increases, the function value decreases. So it gets closer and closer to 0. And I want to just mention that this would be, we would see something like this where, you know, if we're trying to save an animal from extinction, this would be the curve that you would have as it approached extinction. We don't want it to go extinct, and we want to stop it before that happens. But there comes a point where the mathematics of this kind of fails, because we don't talk about, you know, having a 0.2 of a, you know, a particular type of rhinoceros. These are things to be aware of. Sometimes your model is not always going to be perfect, but you want to be at least aware of what's happening. Think about the context as well as the mathematics. But here you have, as the time is going past, or whatever is going past, this is going decreasing. All right, so, and in this case, again, we're going to have it go from our 0 up to, it goes up to a positive infinity, or it comes from a positive infinity down to 0, if you prefer to think about it like that. But that is going to be your range. All right. All right. So people kind of wonder about, well, which is faster, which is slower, and the answer is it depends. If you have a situation where you have your base, your a, is greater than 1, the larger the absolute value of that number, the faster it increases. All right. So the larger absolute value of a in this circumstance, the steeper the function increases. All right, in this case we have a 1.8, which, you know, kind of, you can see it's going up, definitely is increasing, and it's not going at a constant rate. It's not a line, but it's going up, but it's not going up as fast as our 2.5. That's a higher absolute value. This goes up steeper, and then our base of 4 goes up more quickly as well. All right, so it's going to, the bigger the absolute value of that base, the faster it's going to go up when our a is greater than 1. okay? And that's we have to be very specific that the A is greater than 1. When A is less than 1, it's almost the opposite, okay? When we have the larger the absolute value, so the larger the absolute value of A, the slower it decreases. Slower it decreases. You can also think about it as being stretched, right? It's stretched. And if you stop and think about the reason why that would be, it actually does make sense. And I want to give just an example of that real briefly. And then we'll go on to our next round of video. All right, so if you have, I'm going to use COVID just because that's the big thing going on right now. If you have COVID virus that are doubling every time, every time over a certain period of time, like every hour they're doubling, you're going to have that base be a 2, right? So if we say, okay, we've got 1 COVID virus at time 0, right? And then we go an hour later, and now we've got 2 of them. And it doesn't take very long before, over a couple hours, you're going to start getting into some bigger and bigger numbers, right? But if I were to start off, say there's a mutation, and they are mutating all the time. Say there's a mutation that instead of it being 4 or 2, it's going to be a 4. So if I have a 4, for every 1, right, for every 1 that I go up on my X, this is going to get me, I'm going to start with I'm going to have a 4 to the 1 is going to get me 4, and then my 4 to the 2 is going to get me 16. Now in the 2 to the 2 squared, right, that's only going to get me a 4. So this is, I mean, you can see that the faster this thing grows, the bigger the base, the steeper it's going to increase. All right. When I'm talking about something less than 1, it is important to think about how is it behaving. Well, if I have a 0.99, right, that's the same as saying I have this base. I only lost 1 out of 100. All right, so I have 99. Yes, it's decreasing, right? If I start off and I go from 1 or 100% and I go down and then I'm at a 99%, yes, I'm moving down. Yes, it's getting smaller, but it's not getting small very fast. Where if I have a case like this, if I have 100, right, that's going to give me my complete 1%. My first hour, right, would mean that I have 25 left, right, because my 100 or my 0.25, right, to the 1, and I should have had this be a 0.25. 0.25 to the 0 is 1. Now I'm going to have only 25 of these left, or 25%. And then I'm only going to have a quarter of that. So I'm going to have, I'd have about a little bit, 6 1/4, right? So for my 0.25 to the second, we're talking about a 6 1/4 of whatever it is I'm talking about, right? So the faster that the smaller this value is in terms of absolute value, the quicker it's going down, because this is saying I still have that much. This is saying I don't have nearly as much. I'm going down much more quickly. So hopefully that makes sense as to what's happening. Again, I'm going to stop here and I'm going to pick up again in the next video.